Hi, welcome to deep learning. Most of the times, we basically tend to think, what is deep learning? What is deep about deep learning? So let's try to understand it. Myself, Srirang Kote. I'll be talking about deep learning. Basically, I am a practicing programmer. I have done a lot of programming. I worked in industry for several years, and I continue to work in deep learning as well as in machine learning. So let's get going. So for today, we'll be covering AI, ML and DL. So let's try to understand quickly what is it. Then we'll spend some time on machine learning. Then we'll go about what is deep in deep learning. So many people tend to ask what is that deep in deep learning. So we'll try to do that. And then what's learning in deep learning. So that's also another point that basically people would like to know. So we'll try to spend some time on that. And then what's next? So basically what are we going to do after knowing this overview? So we'll try to understand this. So let's get going. So once again, welcome to this presentation. So AI, ML and DL. This is a very commonly seen diagram. Most of us basically, whosoever have attended or have seen any presentations about artificial intelligence, machine learning and deep learning, they tend to start with this diagram. So am I. So I basically have used the same diagram where we see that artificial intelligence is at the outer oval, then within that there is machine learning and then the deep learning. So as such, from the diagram we are able to at least make out that within artificial intelligence there are two subtopics, that is machine learning and deep learning. So let's get into it now. So artificial intelligence. So basically AI is a general field that encompasses machine learning and deep learning, and that's what I think the diagram was trying to show. So where was it useful? So typically people were using it and they still use it to solve well-defined and the logical problems. So what can be an example of that? So let's say I want to basically develop a program and where I'm going to play the chess. So I know that when I play the chess or when I write a program for chess, then there are very clearly rules are there, very explicit rules are there. So if such is the situation, then people tend to use artificial intelligence. There is a history to it, will not go into that. So I'm just trying to summarize a few important things about it. So essentially artificial intelligence, people tend to think more from the explicit rules. But when I have a situation which is a complex situation, like if I have to solve the problems, like for example, image classification, speech recognition and language translation, and in that case, in this particular these examples, typically it becomes intractable to figure out the explicit rules. So in such situation, typically people came up with a new approach, and that approach is actually called as machine learning. So from AI, people migrated towards slowly towards machine learning. So when they started thinking about machine learning, the thought process was, could a computer go beyond? Beyond what? So beyond what we know how to order it to perform, and learn on its own how to perform a specified task. Because still now people were comfortable about defining the rules and just trying to get it executed. But here now, can a computer go beyond that particular thing? So could a computer surprise us? Like rather than programmers, people like us basically crafting data processing rules by hand, could a computer automatically learn these rules by looking at the data? So that's a very interesting thought process. Like, can computer learn these rules and by looking at the data? So that's where the machine learning came into it. So what do we do now? So here we have this input data as well as the answer. So that means now you are going to input data as well as the answers expected from the data. That means now my input is data and the answers, and the outcome of this whole approach or whole process will be a rules, or outcome will be the rules. So let's try to depict it. So typically in the classical programming you have this rules and data. which are the input, which are fed basically, and then when I write a program, then the output will be the answers. So now this thought process is changed, and now can I have data and answers as the input, and then as part of machine learning you basically come up with the rules. So what is this? So ML system is trained. That means it tries to find statistical structure in the example. That word statistical structure is very important. So it tries to find statistical structure in the examples. Then once you have this statistical structure, can I apply those rules to the new data? Because I have used certain set of data, I came up with the rules. Now those particular rules are there. Now can I apply those rules to the new data to produce the original answers? So what does that ML model do? So ML model will find appropriate representation of their input data. So whatever the data that I have fed, so it is going to find on its own the appropriate representation of the input data within a predefined space of possibility. That means basically it is going to figure out what basically a particular model will suit for that particular data that I am feeding, and then it is going to make use of guidance from the feedback signal. That means there is some sort of feedback also is fed, and then it's going to learn based on that. So let's now get into deep learning. So what is it? Because just now I have spoken about few things about machine learning. So what is deep learning about? So it's a specific subfield of machine learning. So it's a new take on learning representations from data. And what is that new take? So I tend to come up with something called as layered approach. So if I have a layered approach, then in that case I am talking about deep learning. So at times people do tend to comment on machine learning as something like a shallow learning. Some people do used to comment on it, and deep learning is obviously where we are talking about now, a new take on learning representation. So the word here is focus is the learning representations from the data, and then we are going to make use of layered approach. So that's basically at the top level. So what is this deep in deep learning? Many people tend to think that if I basically say that deep, that means मैं कुछ डेफिनेटली डीपर जा रहा हूँ या कुछ और कुछ करने वाला हूँ जो कंपैरेटिवली मशीन लर्निंग नहीं कर पा रहा था. So let's not get into this. So it's not a reference to any kind of deeper understanding achieved by the layered approach. So what is it now? So it puts a focus on successive layer learning. So that means learning successive layers of increasingly meaningful representation, and that's what I told. The focus is on learning representation. So it's going to emphasize on learning successive layers of increasingly meaningful representations. We'll see this in an example shortly. So what does basically it stands for? So it stands for this idea of successive layers of representation. So the other name that has been coined for deep learning is basically a layered representations learning. At times people also call it as hierarchical representation learning. So it's not like any kind of deeper understanding achieved by layered approach, but it's more like the learning successive layers of increasingly meaningful representation. So emphasis on learning successive layers of increasingly meaningful representations. So that's basically the deep in deep learning stands for. So layered representation is now I have started using the word layered representations rather than using the deep learning. So let's get into it. So layered representations are learned via models called neural network. So now neural network is another new word that we have started. Just I have told you. So new layers are stacked on top of each other, and then neural network is a reference to neurobiology. That means drawing an inspiration from our understanding of the brain. So whatever the way in which humans try to, whatever the understanding of the brain, inspiration from our understanding of the brain, that is what basically people have started talking about when they think about a layered representation. And the layered representations are learned via models called as neural network. So does it model brain? So that's a simple question that comes into many people's mind, does it now going to model brain? And many people think like that. However, deep learning models are not models of the brain. Why? Because there is no evidence that brain implements anything like the learning mechanisms used in deep learning models. So anyway, whenever we will go into deeper understanding, or whenever we will go into the course details about deep learning, we'll understand what this point is. But DL models are not models of the brain. However, neural network is a reference to a neurobiology, but the overall DL model or the deep learning models are not the models of the brain. Why? Because there is no evidence that brain implements anything like learning mechanism used in modern deep learning models. So what is it? So what it is? That's basically the question now. So what is it? So it's essentially a mathematical framework for learning representations from data, and that's what again I have started emphasizing the point, learning representations, and that's what I told you even in the few slides earlier. So deep learning is a mathematical framework for learning representations from data. So let's take an example. Now let's say I have a handwritten digit, say for example number 5, and this is a these are some of the standard digits that are available in literature. So let's say I have a input data. So now I have these different layers are there, and those layers are going to aid me, or they are going to help me by having the learning representation. That's again concentrate on that word. It's a mathematical framework for learning representations from the data. That means the input data is a handwritten digit that is given, and now you have these different layers, layer 1, layer 2, like that, and then at the end of that final layer, so for example here layer 4, then you are able to say that the input data is basically 5 number that is entered. So let's go into more detail of this. So let's take this example. Now you have this original input 4, let's say it's a handwritten number 4, and now you can see that layer 1 representations, layer 2 representations, and layer 3 representation has some or the other information that aids me to come up to the conclusion that the original input is a digit 4. You can see that lot of times those 4 in the layer 1 representation, or in layer 2 representation, or in layer 3 representation, you can't individually, you cannot say that it's a letter 4 or it's a digit 4. However, each has part information, and that part information is essentially going to take a decision, is going to help me to take a decision that the input number is digit 4. So the classification is very important. So what does this network do? So network is essentially transforming the digit image into representation. Again, that point is about the representation, and the representations are different from the original image and informative about the final result. That is the point that I was trying to say, that all that information is going to help me or aid me to take the decision that the final output is going to say that it's a digit 4. So in this now we have started talking about another terminology called as deep network. So what is it actually going to do? So deep network is what it is. So essentially it's a multi-stage information distillation operation. That means you have different stages, and you are actually distillation operation, the way in which we put it in chemistry or in so basically that is what, so we talk about it. So you are trying to distill it. So multi-stage information distillation operation, where information goes through successive filters and comes out increasingly purified. So that is where we talk about a deep network. When it comes to machine learning, people talk about it something like a shallow learning or a shallow network. So deep learning is what? So it's a multi-stage way to learn data representation. Again, you can see that I'm talking about the representation word. So data representation happens to be the important thing, and where the layers are aiding me to represent the data. So the different layers are there. So they are aiding me. So essentially it's a multi-stage way to learn data representation. So let's now focus on learning in DL now. So learning in DL is essentially what? So let's now try to do that. So now you have this basically a input X, and then you are giving this input X to the layer, say another layer, and then it is coming out with the output which is called as predictions. And now you can see in the diagram there are weights are shown as part of on the left hand side of the diagram, okay, and weights are fed to each layer or the data transformation, because layers are going to do the data transformation. So what my job is? So job is actually to input to target mapping. That is what basically I want to achieve. So input to target mapping is done via deep sequence of data transformation. That's what I have said, it's a layer. So you basically keep on doing that transformations, and layer is helping me to do that. That is, the data transformation is done at the layer, and you are able to take the final call or the final decision that this is that particular input is fed. So the data transformation, that means at the layer, are learned by exposure to the examples. That means whatever the examples that I am giving, that is the input, so it is able to learn. So what specifically a layer does to its input data? So that particular thing is taken care by something called as the weights. That means weights now play an important role in deciding what a particular layer is going to do for that particular input data. That means suppose I have given input X to the layer, then from that layer some output has come, and that output is given to say another layer. So again, however, for each of those layers there are weights. So the weights plays a very crucial role or an important role. So what that particular layer is going to do to the input data, that is basically governed by the weights. So learning means finding a set of values for the weights of all the layers. So such that, so why should I do that, or why it is required? Because such that network will correctly map example or the inputs to the appropriate target. So what is the aim now? So probably you could have guessed it. Yeah, so the aim is to find right values for weights. So now we have spoken about finding right values of weights, but there are several weights. So people at times also call it as parameters. So now in this diagram you can see that I have shown the weights, and then there are predictions, and now I want to basically calculate those weights, but they are several in number. So what should I do? So I need to take care of something which is going to do controlling for me. So to control the output, you basically measure how far this output is from the expected. So that's where this topic, or that's where this point of loss function comes. So you tend to define a function which is basically called as a loss function, and it takes predictions and the true target. So true target is the actual value or the real value, and the predictions is what I have done using my layered approach or the data transformation approach. So score is going to tell me how well this whole network has performed or based on for that particular input. So this loss function plays a very important role. Now I am going to make use of this score. So whatever the score I have got, so because the loss function is going to give me the score, so that score I am going to use. So use this score as the feedback signal. Then you adjust the weight so that loss score is lowered, and then you basically implement something called as optimizer. So that optimizer will be responsible for propagating. So let's now see this in the diagram. So you have this layered approach where you have different layers to it. You have the weights because they are going to govern how the transformation is going to happen. Then you are going to get predictions. You are going to feed it to the loss functions with the true target. Then you are going to get the score, which is a loss score, and that particular thing will be input to the optimizer, and then the output of optimizer will basically update the weights. And so what we are doing is essentially we are propagating it backwards. That's where the backpropagation algorithms comes into picture. So essentially what we are doing is, initially the weights can be randomly assigned, then because it's a randomly assigned, so obviously there is a chance that the output is far off. It's not what we basically, it's nowhere near to the true target. So loss score is very high. That means there are a lot of errors. So with every example, that means with every data, the network is going to process, because input is an example. You are trying to process that. So weights will be adjusted a little by little in the correct direction, because this itself is an algorithm, and so that the loss score decreases. So whole this approach is essentially becomes a training loop. So let's now, having learned this his background about the deep learning, we started from AI, then we came to machine learning, and then we learned a little bit about the overview about the deep learning. We'll now try to see some examples where this DL ML combination or the DLs are used. So image classification is a very classic example. Then speech recognition is one thing. Then machine translation, so people use that. Then the product wise, actually you can see Google now, Amazon Alexa tends to make use of this approach. Then advertisement targeting, so based on your browsing, Google uses it, Baidu, Bing. So these are some of the examples where improved advertisement targeting can be done. Then ability to answer natural language question, so NLP type of approach basically is also part of this. So these are some of the practical examples, and the product where deep learning basically makes use of it. In Google, we know that Google, Amazon heavily uses it in their in their product. So what next? So as a part of this curriculum, or as a part of this overall deep learning course, we are going to basically do this course in Python. So obviously a decent knowledge of Python is good enough. So we are going to, first thing is we are going to explore building blocks of neural networks. We'll try to understand data representation, the tensor, what is a tensor, then what is this backpropagation which I just mentioned some time back. Then we are going to understand Keras, which is a library by Google. So we are going to understand the different data sets, then we'll apply Keras to real examples, case studies. Then at times we come up with a design decision, that is overfitting, underfitting. So we'll try to understand that. Then we'll apply it for image processing. Then we'll try to understand what is convolution neural network, convnets it's called. Then we'll try to understand what are the different features, what is pre-trained convnets. Then we'll also apply to text and sequences, where we have text data. Then we can use RNN, which is another form of model. Then LSTM, so we'll see this RNN, and then the recurrent neural networks, and LSTM, which is essentially used for sequences and the time series type of approach. Then we'll go beyond what we are learning this, and there is something called as functional API, which is an advanced topic. So we'll see this. So this is the overall curriculum about the deep learning, and we'll be using Keras along with the Python. The focus will be doing a lot of things practically or hands-on, and wherever required we'll give theory, but more focus will be on practical aspects about the deep learning and learning in depth. So this was the overview about the deep learning and the course that will be part of this deep learning. Thank you.